So what we have here is the aerial technology. It's a haptic technology that creates tactile sensations in free air. And basically how it works is we have 5 speakers around an enclosure that when the speakers displace, they compress the air and force it out the nozzle and it creates a vortex. And so when the vortex goes out, it hits your hand, and we have a flexible nozzle here that allows us to control where the vortex goes. And so we have a nice little demo here to showcase the technology. So what we have here is a butterfly, and it's trapped in a polygonal world, and we want to bring it out to, we want to basically bring it outside to safety here. So we have a little window, and you're going to pick up the butterfly and move it to the window. So I'm just going to start by touching the surface. This is just a Microsoft Surface. And as I bring it up, the devices activate, and you can see the butterfly's on my hand right now. And the flexible nozzle is just moving around to track my hand. And so what we have there is a little tiny PMD depth camera. It's a little tiny depth sensor. It's tracking my hand. And then as I move it towards the window, the butterfly starts getting excited and the vortices start pumping faster. So you can see the wings are moving very, very quickly, and that's just increasing the number of vortices that are hitting my hand. So it's kind of going really, really fast right now. And as I go all the way to the window, I let it out, and now it's out into the world to safety with its other butterfly friend, and then we'll have it come back around for the next person to use again. And the basic idea here is we've created a couple zones to show where the frequency changes to give people a sense of how powerful the vortices are, and we have a very light flutter. So to give you a sense of what that feels like, it's basically just a soft air puff touching, kind of bouncing off of your hand to match what it might feel like to have a butterfly's wings fluttering on your hand. Now, if you actually had a physical butterfly on your hand, you probably wouldn't feel very much of anything, but it's a nice way of showing the technology that we've created.
So this is a quick tech demo that we have set up that shows the device in action. We have in the front here a flexible nozzle, and the nozzle can be rotated to point in any direction within a 70-degree field of view. And the advantage of that is that means we can track your body, we can track different users, and hit specific parts of them with the vortex to give different haptic sensations. The device is capable of generating a lot of different vortices. Here we have a high-frequency vortice. This is basically a number of vortices firing 10 per second. And this is a much stronger vortex, and we're firing this one at a much lower frequency. This is about 1 per second. The vortices are created with these 5 subwoofers we have mounted around a 3D printed enclosure. When they all are actuated at the same time, they force air out through this nozzle. And this nozzle is designed specifically for this volume of air to give the best vortices that we can. And they last for about 1.5 meters.
So this aerial technology here is, as you can see, is almost entirely 3D printed, with the exception of the actuators, the speakers, and the motors. It's almost all 3D printed, and we have a nice flexible nozzle here. As you can see, it's one 3D print. So what we do is we put this into a 3D printer, and it can print both this flexible material and this hard shell here. And when the UV material on the print cures, it hardens, so it becomes one fused 3D print. And so what this does is it allows us to very quickly prototype a bunch of different nozzle designs to figure out how we can most accurately create these vortices that we're shooting out for these different applications. And so where we feel all this fits into the big picture is this is kind of a way to create these sensations in midair. It's another way of saying, well, computing has mostly been relegated to the desktop, or we've had computing now with touchscreens and our mobile devices, but there's been a big push recently with getting computing out into the real world. So being able to gesture with your body to interact with computers. And one of the fundamental challenges there is you don't get any physical feedback. If you're playing a Kinect game with your entire body and you're gesturing, you don't actually feel anything. So this is one very important piece of technology that allows you to get that physical feedback. And with this we can create entirely new augmented reality experiences. We can have butterflies fluttering around on your arm and your body. You can play a virtual soccer game that you feel a soccer ball getting deflected away from you. You can do all kinds of really, really cool things with free air haptic technology. And so this is just the beginning. We have a lot of fun ideas planned. We want to take this and scale it up, have it go all the way up to large scale environments, so have multiple projector camera system units put together to have these aerial devices shooting things at you while you see projection on your body. We want to have remote telepresence applications, so if we scale it down so that it's small enough to go on your mobile device, you can do remote telepresence. And then have a bunch of different sensing techniques. So try to make everything kind of fit together in this new augmented world that we have. And so hopefully this gives you an idea of what's possible. Hopefully we'll be able to continue developing it and do some fun stuff in the future.